Now we are going to see about a limiting reagent. Stoichiometric reactions helpful to identify the amount of product is formed or the amount of reactant is required for the particular formation of the reactant. But limiting reagent means in chemical reactions, one of the reagent is fully converted into the product. That reagent is called a limiting reagent. That is, in one chemical reactions, only one reactant is fully converted into the product. That type of reactant is called a limiting reagent. For example, sulfur is interacting with 3 moles of fluorine to form a sulfur hexafluoride. Here we are putting excess of an fluorine. In this case, sulfur is also forms sulfur hexafluoride. Here the excess of fluorine is there, but the sulfur is not there. So in this case, in this type of reaction, sulfur only fully converted into sulfur only completely involve the reaction to form a sulfur hexoxide, sulfur hexafluoride. So the sulfur is called a limiting reagent. If excess of fluorine is present, it is not useful for this reaction. So sulfur is called a limiting reagent. In stoichiometric reactions, we are easily identify this limiting reagent, but in the case of non-stoichiometric reactions, how do you identify the limiting reagent? Do you have any ideas about this? In this case, yeah, one of the reactants readily involve the reactions. One of the reactants readily involve the reactions, chemical reactions. That type of reactant is called a limiting reagent. In non-stoichiometric reactions, we are easily identify the limiting reagent. In non-stoichiometric reactions, one of the reactants readily involve the chemical reactions. That reactant is called a limiting reagent. And this calculation is expressed as this calculations is used to identify the, how we have to calculate the amount of product, how we have to calculate the amount of reactants, what we are identifying a limiting reagent. In the sums, they are asking about which one is a limiting reagent and calculate the quantity of urea formed and unreacted quantity of excess of a reagent here. And this tablet column is helpful to find out all the questions, answer for all the questions. Yeah, they are framing in one of the tablet column. Before framing the tablet column, we have to balance the reactions. The 2 moles of ammonia react with 1 mole of carbon dioxide gives 1 moles of urea and water. Here, reactant product stoichiometric coefficient is ammonia. Ammonia is 2 moles of ammonia. So stoichiometric coefficient of ammonia is 2, carbon dioxide is 1, and urea is always 1. Then water molecule is also 1. Then number of moles of reactant allowed to react. In our sums, they are giving they are all also giving a mass of an ammonia. Mass of an ammonia is 646. They are given in sum, which is given in sum, which is divided by molecular mass of ammonia. Molecular mass of ammonia is nitrogen is 14 plus hydrogen is 3. So molecular mass of ammonia is 17. 646 is divided by 17. We can get a 38 moles. Here we are calculating a number of moles. Number of moles is nothing but mass divided by molecular mass. Given mass divided by molecular mass, it gives a number of moles. In carbon dioxide mass is also given in reactions, which is 1144, which is divided by the molecular mass of carbon dioxide. Carbon is in 12, adjacent to oxygen is there, so 32. So molecular mass of carbon dioxide is 44. Here we are getting 26 moles of carbon dioxide. Then that is ratio between the reactant. After that we are calculating the ratio between the reactant. That is 2:1. 2:1 ratio. ammonia and carbon dioxide interact to form a urea. So 2 moles are, which is equivalent to 38 moles. If 1 mole is equal to 19 moles, 2 moles are 38 moles, means 1 mole we know that 1 mole is 19 moles, then only the 2 moles are 38 moles. That's way they are calculated. It is a reaction ratios. Ratios 2:1. The ammonia and carbon dioxide ratio is 2:1. Then only they are writing, and 2 moles of ammonia interact with, so 38 moles interact with reactions. 1 moles of carbon dioxide interact with reaction, which is exactly equal to 90 moles. The number of moles of product means here the 1 mole is equivalent to 90 moles. Urea is also 1 mole and water is also 1 mole. The number of moles of the product should be in a one stoichiometric coefficient, which is equal to 90 moles. Then another one stoichiometric equivalent to 19 moles. The number of moles of the reactant left at the end of the reactions. Here 38 moles, we can take a 38 moles. 38 moles is involved the reaction, so 0. Ammonia is on a 0. In carbon dioxide we have to take a 19, we have to take a 26 moles, but it involve only 19 moles involve the reactant. The remaining is 7 moles. In the case of product, in this case they are asking about only a reactant, so we won't calculate the product here. This tablet column is very much used to identify the answer. Now they are asking a question: what is the limiting reagents? Which reagent is fully among the ammonia and carbon dioxide? Which reagent is fully converted into the product? In this case, carbon dioxide has a remaining 7 moles, but ammonia is fully converted into the product. So ammonia is called a limiting reagent. Ammonia is called a limiting reagent. Then another question: calculate the quantity of urea formed. The formation of urea is 19 moles. Quantity of urea means mass of one urea. Mass equal to mole. Mass equal to mole into molecular mass. Mass equal to mole into molecular mass. Here mole is 19. Molecular mass of urea is 60. Molecular mass of urea is 60. So the answer is 1140. That is, calculate the quantity of urea formed. Calculate the quantity of urea formed is 1140. Then an unreacted quantity of the excess reagent. Here unreacted quantity of excess reagent is carbon dioxide, which is formed 7 moles. Mass of carbon dioxide is 7 into molecular mass of carbon dioxide is 44. The answer is 308 grams. So the unreacted quantity of the excess of reagent is 308 grams.